Thank you for joining. It's about distributed object graph with MicroStream. Yeah, it's a really fantastic experience to be back in a cinema. So it's, for me personally, 4 years ago at GeeCON conference, last time we were in a cinema. All of the other talks were online. Now it's great to see the audience. So let's keep it interactive so you can ask questions anytime. Try to answer your questions. So before we start, first of all, we have some gift for you. You can register for a free online training courses. So they are sponsored by Java Pro magazine and MicroStream. So we have trainings about Helidon, Markus, Král VM native images, Spring Boot, Micronaut, so all of these micro runtimes. Scan the QR code, then check out which day it fits for you, and then you can enroll for free. We have around 100 seats for free. So I will show the slide at the end again. You can check it out. Of course, you can also invite your colleagues and friends. So I've prepared a small video because we're in a cinema, so let's show a video. So it's because of data. So more and more companies globally, they have to collect more and more data, and from various applications, they have to collect data, connect data, searching data, tons of data in real time, because all of these modern applications, they are data-driven, and we need to consume tons of data. And the best case would be if all of this happens in real time, right? And so the question is, are we able to deal with this low latency applications, and how can we build the fastest application with Java? And latencies are really expensive. Interesting study. Amazon, they found out that 100 milliseconds of latency cost them 1% in sales. This is really incredible. But we believe with Java, we are able to build the fastest applications on the planet. And this is what this talk is all about. And I will show you how you can achieve this and how easy it is. My name is Markus Kett. I'm CEO and co-founder of MicroStream. We are super proud to be contributed to Project Helidon also. We also contributed to Project Micronaut. We run 2 other open source projects. One of these is Rapid Clips. And this Rapid Clips project is was our first project. It's a visual development environment, and with my team, we have been working on Java since more than 15 years now. With Rapid Clips, we wanted to build a visual Java development environment, so similar to Visual Basic, but for Java. And this was our goal. And the problem was, as soon as we wanted to store data, then it was very complicated. So building graphical user interfaces that worked really pretty well, but as soon as the users wanted to store data, they had to deal with Hibernate, and so this was mostly very complicated. And this was the reason why we have worked on improving the JBoss Hibernate tools, make it more simple and faster. So we spent 7 or 8 years to work on that. Then we saw it's really hard to improve it. So this was the reason why we started the MicroStream open source project. So first of all, I like to show you a demo. Then we talk about what actually is Helidon. Then I like to talk a little bit about why traditional databases are challenging in terms of performance, and how MicroStream, the functional principle works. And then we talk about distributed object graphs with MicroStream, and I'm sure we will have some time for Q&A. Why distributed object graphs? It's because with distributed object graph, with MicroStream, you will be able to build the fastest application. So with Java, with pure Java, and the application or also microservices. Okay, let's get started with what actually is Helidon.
All right. Hello, everyone. My name is Král, and I work in Oracle and as a member of the Helidon team. I am here to make a basic introduction to what Helidon is for you who do not know that. All right, so Helidon itself is a collection of libraries for writing microservices. It is based on Netty, so our server and also, as well the clients are very fast. Helidon itself is cloud native ready, and that means that all of our components we are providing, we are designing those and basically creating those with the size of the component in mind. So we are really trying to, for your resulting application, to be to have the smallest possible footprint what it needs. Helidon itself have two flavors. The first one is the Helidon SE, and the second one is the Helidon MP. Both of the flavors are providing similar functionality in certain ways, but they are very different in terms of the user developer experience, let's say. Let's start with the Helidon SE. The Helidon SE is specific with its reactive APIs and heavy usage of the functional style of programming. With Helidon SE, you are basically given full control over your server. You are having, you have to do everything yourself. There is no magic happening behind the scene without your knowledge. So, and by magic, I mean, for example, something like CDI or annotation processing, such as, let's say, the JAX-RS annotation processors and stuff like that. On the other hand, we have the second flavor, and that's the Helidon MP. Helidon MP is basically the opposite of Helidon SE, and that means it provides, let's say, more common way for developing microservices. You can simply use your JAX-RS annotated resource with it. We are providing there several Jakarta EE specifications and as well their implementations. And other than that, we are also adding their microprofile implementations and the specifications. With the Helidon version 3, there is microprofile version 5 supported right now. We are writing the implementations of the microprofile specifications ourselves because we would like to be able to react on possible bugs or improvements and stuff the fastest way possible, because we are the one responsible for the implementations, and if there is anything incorrect there, we will create a fix and we can make a release. We do not have to wait for anyone else to do it for us, and because of that, there is no delay in that. All right, so which flavor you should choose is, it depends on your use case. For example, if the performance is something you really focus on, that's something you really need to make your application fast as possible, well then Helidon SE is definitely your good candidate there, because there are no dependencies whatsoever which could slow your server and stuff. But if you are unsure or you are more, let's say, familiar with the traditional way of programming, well then Helidon MP would be probably the better for you. Other than having the SEM MP, we are also having a different framework integration, and one of those integrations is actually a MicroStream integration. We have developed this integration with tight cooperation with the MicroStream guys, and I have to say it's really great to have teams which are open to cooperation like that to ensure that you will have the flawless experience possible when using the integration itself. And with that, that's basically everything from me. That's the introduction to Helidon, and I'm giving the stage back to Markus. Thank you.
Thank you, David. So actually, I'd like to show you small performance demo, and this demo also runs on our website, so you can check it out anytime, and the code is on GitHub. You can play around, implement your own queries, and here this shows two applications are running here in parallel. It's a simple bookstore demo. We have around 250 gigabyte data in the database. Here we use a PostgreSQL database. And one application is built with the traditional Java stack. We use here JPA, and as an implementation we use Hibernate and cache. And by the way, this is a hot cache because the application runs all the time. The other implementation is built with Helidon and MicroStream as a persistence. And here we can see all queries are executed sometimes 10x faster, mostly more than 100x faster, but many queries are also executed up to 1,000 times and even more, even faster. So the question is this a trick? It is not. It's you can really play around and check it out, implement your own queries and try to beat it with a database. You also can change the database. How does this work? So I will explain how this works now in the upcoming 40 minutes or 30 minutes we have for that. And 1000x really means this is really incredible. So here you can build really the fastest applications on the planet. Why traditional databases cannot achieve such a performance, actually? Let's have a look on how traditional database applications work. So we try to work on JBoss Hibernate tools to accelerate Hibernate, but this is challenging. Why? Because here you can see architecture of a common Java application. We have our business logic. It's an application or microservice, doesn't matter. We have the objects in memory, and we have the JVM. Or perhaps we have, when we have a microservice, we have a native image. Everything is object-oriented in Java, right? So even data are also object. We have objects in memory. But as soon as we want to store data, then it becomes challenging because if you use a relational database, then we have to deal with tables. So, and to store more complex objects in tables, this is actually not possible. Why? It's because the data structure are completely different and they are incompatible. It's called impedance mismatch, and we have several impedance mismatches here. So, for instance, the object model can be much more granular than the relational model with only tables and columns. Then in Java we use subtypes. If we have an object graph, then we can really easily go through an object graph just by calling get methods. Then in Java we only have some primitive types. In databases we often have more than 30 data types. So and both do not match together. This is really a problem through development time and also through runtime. What's about NoSQL databases? Now, NoSQL databases, they introduce completely new data structure or formats. So we have column stores, we have JSON, XML, we have graph databases, object-oriented databases. But no matter which database you use, all of these data structures are proprietary database, or at least database-specific data structure or formats. They are not compatible with the native Java object model. So they are also incompatible, so we have the same challenges here as well. How do we solve this problem? So to solve it, we need an object relational mapping or a data conversion between our application and the database. So for instance, we use Hibernate for that. Object relational mapping means, or data conversion means there is a delay, there is a latency through every single read and write. And if you measure it, then perhaps you will measure that it can double your query time. And we talk about millisecond query time. So this might be slow down your application. And to solve this problem, to accelerate your application, we are used to add a cache here. But we can see our complexity increases. Now we have a local cache, so we can store our result sets in memory, and that's good because memory is fast. So now the application should be faster. But in practice, we are very often dealing with distributed applications. So, and we have multiple instances of our app or microservice. And let's say one of these application nodes or service change an object and store this object in a database. What happens? Then this node and the database are in sync. The problem is all the other nodes are not in sync with the database. This is really challenging. What we can do to solve this is now putting the cache between the application nodes and the database. In practice, of course, we're in a cloud, so we try to avoid single point of failures, so which means we should have a distributed cache in between. So we can cluster our cache. Then we have a distributed cache, like Redis or Coherence, for instance. And so now we are able to solve this problem. But now we can see complexity increases more and more. We need additional machines, additional CPU power. So and our costs of infrastructure will also increase. If the load now goes up, then perhaps it's a good idea also to cluster the database. So we add a database cluster as well. And this is then a common enterprise database application. We have 3 tiers, we have 3 clusters, lots of machines are running here, lots of CPU power, and high costs of infrastructure. So we believe that, and we have proven that in Java in-memory data processing is extremely fast. And this is what you have seen in the performance demo. Java in-memory data processing is extremely fast. Here we can see some numbers from GitHub. Why is in-memory computing so fast? So it's up to 100,000 times faster sometimes in comparison to a hard disk. But mostly up to 1,000x faster. So if we can process our data in memory, that's cool. And we believe we do not need anything else but Java to do that, because of this just-in-time compiler of the JVM. Java applications are really fast, incredible fast. And now with GraalVM, we have the possibility to create native images. So Java itself is fast. Everything what happens in the memory, what is done by Java, it's extremely fast. We have seen with Helidon, we have really fast runtime for executing our microservices. And Java provides the perfect data structure. So the database vendors, they are still searching for the perfect data structure. Some of them now have multi-model databases, because with microservices you have to deal with various data structure. But with Java we have already the perfect data structure from the beginning, because we have object graphs. With an object graph you can store simple objects, you can store a simple list, but you also can create a very complex model with using circular references, for instance. So you can do almost everything. We have a multi-model data structure already. And we have the perfect query language, because we have Java 8 Streams API. With Java Streams API, you can search on object graphs and filter in microseconds. So check it out. Even if you have a terabyte memory, data in a memory, even if you have complex data structure, circular references, you can search it in microseconds. And this is the performance that I have shown in the performance demo. It's type safe, it's fully object oriented, fantastic. In comparison to a database query, we talk about microsecond query times. In comparison to JPA query, comparable millisecond query times, up to 1000x faster. Why don't we use it? It's because a small piece of puzzle is missing in the game. It's how can we store object graphs persistently and restore it in memory when it's needed. With MicroStream, we follow a concept. It's called system prevalence. So we have not invented it, so it was already there. It's really a simple concept, and the functional principle seems really super simple. It's because keep your data, keep your object graph in memory, do everything in memory, search in memory, then everything will be super fast. So if you have enough memory, then you're super lucky. And of course we need persistence. Just create a snapshot of your system state. This concept was defined 15 years ago. But there are many challenges because of, you don't want to create a snapshot of your complete database all the time. Perhaps you don't want to keep your complete database in memory because your database size would be limited to your RAM size, and memory is still expensive. When this concept was written, then they assumed that in 20 years memory will be super cheap, but it's not. So there are really many challenges and open questions. And with MicroStream, now we have saved all of these. So we have eliminated all of these challenges, and we answer all open questions. And this is what MicroStream actually does: storing and loading object graphs. And by the way, it's completely open source. And here, MicroStream in a nutshell, what it is a Java micro. We call it micro persistence because it's so small and has no dependencies. It works great for microservices, but it also can be used with monolithic applications, of course. It runs within the JVM process of your application or your microservice, so it runs embedded. And it enables you to store any kind of object graph, any complexity, any size, any types into any data storage. And vice versa, it enables you to load the entire object graph, but in practice mostly subgraphs when they are needed, into the memory and restore your object graph in memory anytime. The loaded object references are merged directly into your object graph, so you don't have to deal with object copies. It's a fully object-oriented programming model, which means you just have to call get and set methods. That's it. So no more classic selects are required. No more query languages required. The project is open source under EPL, so Eclipse public license, so you can use it for commercial purpose. The code is on GitHub. You can download MicroStream via Maven and include it very easily into your app or microservice. So we are super proud to be integrated with Helidon, and thanks to the Helidon team. So Helidon, they were the first, they integrated MicroStream, and we believe both fit very well together, and so it's a great combination to build ultra-fast microservices. So let's see how MicroStream works under the hood. So what we have done, let's have a look into the database system, because mostly the database is a black box for us. So just send an SQL, get some results back. When we look into the database, and we see we have of course business logic. Java developers mostly have no business logic in the database, but the vendors, they tell us, hey, you have stored procedures, stored functions, put your entire business logic into the database. So with Java, we do it differently, mostly. So we don't need business logic in the database. But we have, of course, also data in memory, because the database tries to keep data in memory to be faster. So it caches data internally. Then we have the database management system that cares for concurrency, locking, logging, and so on. And then we have the storage data on disk. Mostly binary format, but sometimes human-readable format. So it depends on the database system. That's inside the database. Okay, then here we have our common application architecture. And now, what we have done with MicroStream, we replace object relational mapping or data conversions with MicroStream as a persistence for object graphs. And now we are able to use our object graph in memory as an in-memory database, querying with Streams API, so we can do everything in memory. So this is now our database, our in-memory database. It's in memory already, which means we don't need a cache anymore. So we can remove the local cache. Architecture gets more and more simple. Then on a database size, we do not need that caching anymore. We do not need a database management system anymore. So we can remove all of this. And the only thing we have to keep, of course, are the persistent data. And here we can see we can store it in any database or in any data storage, which means we can use plain files, but we also have connectors to databases because we store all of these changes in a binary format. And of course, then we can use plain files, but also we can use databases because databases are able to store binaries, right? So we do not use their proprietary format or data model, but we can use it to store binaries. Does this make sense? From the technical perspective, perhaps it does not make sense. But we can use the backup functions, and sometimes in companies, the database has to be used. So then it can make sense to use the existing database system and store the binaries in a database system. It's very recommended, by the way, to use blob stores. So the modern cloud blob stores, like we have in Oracle Cloud or AWS, they are made for storing binaries. They care for high availability, so this is really recommended to use them. MicroStream as it is runs almost everywhere where Java runs. The only requirement is really Java version 8. It runs on a desktop, on a server. It runs in the cloud. You can run it in a container. Then you can use the volumes to store your binary data, or, as I mentioned, blob stores. It runs with GraalVM native images, so almost everywhere. And also we have an implementation for Android, which is pretty much the same API. MicroStream serialized the changes to disk, and to be able to do that, we built a serialization from scratch completely. because with Java serialization we had some limited and security issues. MicroStream is around 10x faster. It enables you to store any kind of complexity in your object graph, so the depth of your object graph is not limited. You do not have to implement serializable, so you can store any Java type, no annotations required, just use plain POJOs. So we have the implementations for the JVM and for Android. Then we have so-called legacy type mapping. It cares for class changes. So this is very important because our classes evolve, so they change all the time. And with MicroStream, we provide a legacy type mapping that solves class changes through runtime automatically behind the scenes. Then we have a so-called system, a file system garbage collector, because all of these changes are stored appended to your disk. So we store binaries appended. So each store is a new binary in your file storage. If the classes change, you have multiple or various versions of your objects in a file storage, and you can decide if you want to keep the older versions of your objects, or you want MicroStream to remove it from your storage to keep the storage clean and small. We have file system abstraction, which means you can store your data anywhere. Database connectors, as mentioned. Then we have a REST interface that gives you access to the storage data. You can also use a graphical user interface to browse through your storage data. Native backup functions. If you want to use plain files, then you can use the native MicroStream backup functions. And converter to CSV and other in progress, so like protocol buffer. And we provide a MicroStream cluster. And this is actually the title of the session. Here you can build distributed object graphs. And this altogether is MicroStream. We have already seen the performance demo. Now, with MicroStream, we are also able to run MicroStream on multiple machines and replicate our object graph through 100 or even more JVMs. And this is really powerful because now we are able to not only build very fast applications, also to simplify our applications, save a ton of CPU power and machines in the cloud. Here we have the look on our traditional application cluster. With MicroStream, now we can replace traditional application nodes or microservice nodes with MicroStream nodes. And it depends on your use case, of course. But with this incredible performance, you'll be able to replace, let's say, sometimes 10 traditional machines with only one MicroStream machine that achieves the same power than traditional application nodes. So you'll be able to save lots of CPU power, lots of machines, and save costs in the cloud. Because now we replicate the object graph in memory, we don't need a distributed cache anymore. So, yeah, because we are able to replicate in-memory data already. So we can remove the distributed cache. We store binary data only. And if we store it in, let's say, in a blob storage in the Oracle Cloud, then we can remove the database cluster as well. So we can remove the database cluster. We only need storage, a binary storage. And we can remove the distributed cache. And now our architecture gets really super simple. And so this is really great for developers because it's much easier to develop, faster development time, and yeah. So but don't trust me. Check it out. It's open source and it's really easy to implement. In comparison to traditional cluster, it's obvious that we save really tons of CPU power, and cluster infrastructure. To build a MicroStream cluster, it's a little bit challenging because all of these Kubernetes stuff, developers mostly don't want to do that, and this is the reason why we currently working on MicroStream Cloud that enables you to provision, to define, and to set up, to run a MicroStream cluster in the cloud with only some mouse clicks. Benefits in development, of course, the simplest possible architecture and implementation, no mappings, no data conversion. It eliminates mappings and data conversion. You only have your classes. There are no more database data models, so you only have to change your classes, that's it. No specific requirements to your classes, no annotations, no superclasses, no interfaces, just POJOs. We have no specific client API, so you can just use REST. Of course, no specific query language because we use Streams API and core Java concepts only. And with the MicroStream cluster, by the way, you get a distributed Helidon application out of the box. Because all of the MicroStream nodes run on Helidon, and by using the cluster, it clusters your MicroStream, everything is micro. So it clusters your microservice automatically. So you don't have to care for how should I build my distributed system. This is really a great benefit. You have seen the benefit in performance. It's really fast. Everything is in memory with Java, microsecond query time. And it's great for low latency applications, and you will get out really huge, you can handle huge workloads and get huge data throughput. In practice, we save up to 90% CPU consumption, and then of course, costs in the cloud. But what's about challenges? There are challenges. Every technology has pros and cons, and with MicroStream we have also cons. It's built for developers. Who of you is Java developer? Sounds good or looks good. It looks good for us, looks good for you. If you're a DBA, I'm sorry, you're out. It's built for Java developers only, and it is a paradigm shift in database programming because the functional principle is completely different. So there is no more remote machine where the database runs and you send a query and you get the results back. So your database is in memory. This is a single source of truth, which means there is no more database management system anymore. In practice, we have seen in so many database projects that Java developers mostly do not use all of this database functionality. So stored procedures, we don't use it. Stored functions, no, we don't like it. We have concurrency handling in the database, so it's super important. Of course, we have it, but we do it for our own, so our business logic cares for validation, concurrency. So many things are, for us, are better when we do it in our business logic, and so we have it under control. But with MicroStream, you have to do this. So you have to care for concurrency. So for some people, this is not an issue. Some people say, oh, this is challenging for me. But you can use all Java concepts, like synchronize. So you can really use whatever Java provides you to solve or to deal with concurrency. There are also APIs existing. So we are looking forward to Project Loon. It will also help us and accelerate MicroStream applications. But as I mentioned, so you have to care for that. You have your business logic becomes the database management system. It's not suited for DBAs, of course. And some point is missing here. What's about SQL? So there is no more SQL. So we have no SQL support for that. Then access to the database by third-party applications. This could also be challenging because many organizations, they say, oh, we have several applications running. They have directly access to my database. By the way, this is also the reason why we have issues in terms of our data consistency, but in practice, this is often the case. With MicroStream, you have to do it correctly. So you have to build a service that enables third-party applications access to your data. So actually, in the microservice world, you have to do it anyway, but for some, might be a challenge. Then we have, of course, you can run and build a cluster for your own. So we are all developers, so you can do that. It's open source. But of course, you have to deal with Kubernetes and all of these cloud features. And of course, this is effortful. And most of the Java developers don't want to do that. And this is the reason why we provide the MicroStream cluster. So it creates the complete infrastructure for you. It creates the distributed Helidon application. It provisions your Kubernetes environment, your containers. You don't need these DevOps resources, configuration, and so on stuff. And also behind the scenes, we have Kafka running in the cluster. It creates the Kafka cluster automatically. So only with some mouse clicks. Yeah. Additionally, the MicroStream Cloud will provide you replication, auto-scaling, so you can define how many nodes can be started in your cluster, and it scales out and scales in terms of the load of your cluster. You can define when new nodes should be started. So you can define that if you have a max load of 80% for your cluster, then the next MicroStream node should be started. So everything can be configured in the cloud. So how does it look in practice? This is not advertising, so these are really numbers that are true. It's production proof. In Munich, we have several applications running with our client Allianz, the insurance company. And there we have replaced a traditional database application and database clusters, and they save up to 90% infrastructure costs with MicroStream cluster. All right, we have some minutes left for questions. So if you like to see some code, you can go on our website. We have really great documentation and check it out. You can ask questions on our booth. We have developers there. They are writing the code, so you can really ask your technical questions. And of course, you can get great T-shirt. All right, are there any questions? Now I should go to the tooling, right? I've never used it before.
It's not visible there. I think you have to move it.
Ah, okay. I can also ask you questions here. Yes, please. Yes, the question was how do the nodes synchronize data? So how does this work behind the scenes? So we have built a cluster infrastructure for that, and here we use a writer node. So the load is distributed by the load balancer, of course. Then we have a writer node that is responsible for all writes, and all writes are delegated to the writer nodes. And then we forward the stores to a Kafka cluster, and all these reader nodes, they consume the stores, the latest stores, and then they are merged directly into the object graph in the memory. And this is the functional principle how we synchronize the object graph between and synchronize and distribute the object graph through multiple JVMs. And it's the cluster solution is not open source. This is closed source, but we currently talk about an open source version. So I'm not sure if we can provide this also as open source, but MicroStream core is completely open source. Does MicroStream replace JPA in the code? No. So it's also not a drop-in replacement. So you cannot keep your JPA queries, and you can keep your classes, but in practice you don't want to do that, because with MicroStream you're able to build your object model completely freely. So you don't have to adopt your classes to a relational model. So you have much more possibilities, and you're fully free to build your object model. So in practice, you will rewrite many query code, and you will also redesign your object model. So if you don't have pain with performance, you should not do that. I would keep it, and it's built for microservices and new projects. So if you run microservices, mostly you have to rewrite your code, or you have to redesign your application anyway. Then MicroStream can be a good fit, but it's not a drop-in replacement. Huge amount data in the data storage. Yes, you don't. So we talk about in-memory. We talk about in-memory computing. Computer does not work anymore.
Cursor is on the other side.
Here is it again. So okay. So you don't have to load the entire database into the memories. You can do that, but it depends on your use case. If you build a monolithic application and you start it and run it for 2 years or so, and startup time is not an issue for you, and you have enough memory, then you can load your entire database into the memory, of course. But mostly, this is not the case. Mostly, you have a microservice, only 1 GB memory or so, and you have, let's say, 100 GB database. Then this is also not a problem, because we have this lazy loading concept. So if you don't adapt your classes, then everything is automatically eager. The MicroStream will load everything into the memory at the startup. But you can define your classes as lazy, and MicroStream then will only load the object ID of your lazy reference into the memory. And then when you call a get method, then MicroStream loads the object reference into the memory. So you can also have a huge database, but only some gigabyte of memory. And this really depends on your use case. And now I don't see the questions anymore. And we are out of time. 18 seconds. Last question, please. Okay, if you have any questions, there's one question. Sorry?
There was a question about
migration. So we have CSV import and export. Data migration is basically easy, but you can, as I mentioned, you will build a new object model in practice, because you now can do it fully object-oriented and in a perfect way. You don't have to adapt your model to a database. So with CSV import-export, data migration is easy. Last question? Okay, class migration. This is an important question. You get a t-shirt for free. So if your classes change, then and MicroStream loads an object from the storage. It compares it to your class. If your class has changed, then the simple cases can be solved automatically. So if you add a field, if you remove a field, if you rename a field, this can be handled automatically by MicroStream. Also, if you change data types, so simple types. If you have more complex changes in your class, then you can define a legacy type mapping. Then you store the object once again, and then you have two versions of your object in the storage, an older version and the latest version, and you can define how the garbage collector should remove the legacy object from your storage and cleans up the storage all the time. So it's highly configurable. Right, if you have more questions, visit our booth and ask the questions directly to the people who write the code. Thank you very much for joining and have a great day at the GeeCON. Thank you.